Okay, this is a problem from chapter 15.7 and using the Kruskal-Wallis technique. And so this student was able to get through everything, I think primarily because you can plug all the data into StatCrunch and use that to get the test statistic and the graphs and everything. But the critical value doesn't come up on StatCrunch. You have to go into the tables for that. And so that makes this problem a little tricky. And there's two different tables to make things even more complicated. Um, there's a one for large sample sizes and one for small sample sizes. So, or large numbers of distributions and small numbers of distributions. This is a situation where um, we've got five different populations, right? Um, one for each day of the weekday, not of the whole week, but just the weekday. So that's we're told if we have four or more populations. Let me read the book real quick. Oh, it's three. If it's more, yeah. If it's four or more of the populations, then it's a large sample size case. If it's three or less, and you have five different samples for each of the populations, then you can use the small data table. So this is obviously the large data, a large sample size case where you've got five different days and more than five samples for each day. Okay, so we're going to use the large table, which ends up being table 8 in your book. I just found a this this is the same table. It's just formatted a little differently. It's the chi-square distribution, and we want to go on this table, and we're looking for a zero point 0.1 level of significance. Okay, so that means we're looking in this column right here, and we have to know the degrees of freedom. Well, the way we find this is k, which is the number of different populations we have, which is 5, right? We subtract 1 from that to get the degrees of freedom. So we're looking for 4. So the degrees of freedom is 4, and we're going over to that column that I said before, which is right here. So 7.779 is the intersection of our significance and our degrees of freedom, and that'll give us the critical value. So I hope that helps on this question, that tricky part.